Hello students, in this lecture I am going to discuss about another type of optical detector, or you can say another type of photoelectric transducer. As I have told you, what is photoelectric transducer? It is a transducer which converts light energy into electrical energy. So here in this lecture we will be discussing the another type of photoelectric transducer, and that is photoconductive cell. So I'll be discussing in this lecture about photoconductive cell. So this photoconductive cell is a semiconductor light detector, or you can say semiconductor optical detector, because this type of detectors are made up of semiconductor material. So in general, semiconductor light detector, they can be divided into two major categories: junction and bulk effect devices. Junction devices and bulk effect devices. So what are junction devices? Junction devices, when a junction device is operated in photoconductive mode, that is when it is used in such a way that it will convert the light into electrical energy, then junction devices need to utilize the reverse characteristic of a PN junction diode, that is reverse biased characteristic of a PN junction diode. Only then junction devices will operate as photoconductive mode, that is converting light into electrical energy. Under reverse bias, this PN junction acts as light controlled current source, that is it is acting as a photoconductive device. Whereas the bulk effect devices or bulk effect photoconductors have no junction, the bulk resistivity decreases with increasing illumination, allowing more photocurrent to flow. So this photoconductive cell that I'll be discussing in this lecture is basically a bulk effect device. So what is a photoconductive cell? It is based on the principle that, like, now only I've told you what are the bulk effect photoconductors. Since photoconductive cell is a bulk effect device, it has no junction. The principle is its bulk resistivity will decrease with increasing illumination, allowing more photocurrent to flow. So it is based on the principle that the resistance of certain semiconductor materials decreases when they are exposed to radiation. How? So let's see the working principle of photoconductive cell, that is how the resistance of semiconductor material is actually decreasing when they are exposed to radiations. That is, when radiations of sufficient energy fall on such photosensitive materials, these radiations cause the electrons to break away from their covalent bond, thereby generating electron hole pairs, which increase flow of current produced by applied voltage. So what I am trying to say is that when these radiations, they are present in the form of photons. So when radiations will strike this photosensitive material, which is made up of semiconductor, so when radiations which is in the form of photons will strike the semiconductor or photosensitive material, these photons are having some energy, and when these photons will strike the semiconductor material, what will they do? They will impart their energy to the electrons which are present in covalent bond in this photosensitive material. And after gaining the energy from the photons, these electrons will break their covalent bonds, and therefore electron hole pair generation will take place. Now since after the striking of photons, the number of free electrons have increased, so this will increase flow of current produced by the applied voltage. So this increase of current, what is happening? Radiation is striking, The radiations are striking the photosensitive material. More and more number of electrons are coming out after breaking their covalent bond, after gaining the energy from photon. So we have more number of electrons, and this number of electrons, they are increasing the current. So the increase of current with the increase in light intensity, with the applied voltage, whatever voltage is applied, with the applied voltage, with the constant applied voltage, when the radiation is striking the photosensitive material, so with the increase in this light intensity, with the applied voltage remaining constant, the current will get increase, which means the resistance of semiconductor is decreasing with the increase in light intensity. So what is happening? With the increase in light intensity, current is increasing, and if current is increasing, means the resistance of semiconductor is decreasing. So we can conclude that with the increase in light intensity, the resistance of semiconductor decreases. In other words, such materials have high dark resistance and low irradiated resistance. Have high dark resistance and low irradiated. Dark resistance means the resistance of the material when it is not illuminated by light. When the light is not at all striking the photosensitive material, means when there is no light striking the photosensitive material, at that time the resistance of photosensitive material is called the dark resistance. So in these materials will have high dark resistance, and when illumination takes place, when the light will strike such type of photosensitive material, then the resistance of these materials decreases. Therefore, these semiconductors are called photoconductive cells or photoresistors, or sometimes light dependent resistors, since incident light effectively varies their resistance. So again, I am concluding what is happening here. Again, let me conclude. So initially, this is the photosensitive material, that is the semiconductor material having the electrons which are binded, which are in covalent bonds. So initially there will be no current, flow will take place through this semiconductor material, or you can say photosensitive material. So no current flow will take place. So this photosensitive material will have high dark resistance, means there is no light initially. Now when the light rays will fall on this photosensitive material, since the light rays are having photons, this radiation is having photons and it is having some energy, so when these photons will strike the electrons in the covalent bonds of this photosensitive material, they will impart their energy to the electrons and the electrons will get free. So with the increase in light intensity, increase in photon is there, and with the increase in photons, more number of electrons, more number of free electrons will be there, and with more number of free electrons, current will increase, and with the increase in current means the resistance of semiconductor or this photoconductor will decrease. So with the increase in light intensity, the resistance of this photoconductor is decreasing. So it is having high dark resistance and low irradiated resistance. And because of this, these semiconductors are all called photoconductive cells or photoresistors, or sometimes light dependent resistors. Now, coming to the construction of the photoconductive cell, basically the materials that are normally used in photoconductive cells are cadmium sulfide, that is cadmium sulfide, then cadmium selenide, then lead sulfide, etc. These are the materials which are used as the semiconductor materials in photoconductive cells. So this photoconductive, how the construction takes place, as you can see here I have shown the construction of photoconductive cell. What is happening, how this has taken place? These photoconductive cells, they are made by chemically sintering the powder of photoconductive semiconductor material. Photoconductive semiconductor material means the cadmium sulfide or cadmium selenide or lead sulfide. I am talking about these photoconductive semiconductor materials. So these photoconductive cells, they are made by chemically sintering the powder of these photoconductive semiconductor materials and after chemically sintering, by chemically sintering the powder of these materials into tablets of required shape. So what is chemically sintering? I'm telling I will be chemically sintering the powder of photoconductive semiconductor material. So what is sintering? Basically, sintering is a heat treatment process in which a large quantity of loose aggregate material is subjected to sufficiently high temperature and pressure to cause the loose material to become a compact solid piece. And the amount of heat and pressure that is administered during the sintering process is slightly less than the material's melting point. So what is sintering? It is a heat treatment process in which large quantity of the loose material is subjected to sufficiently high temperature and pressure, where the temperature and pressure should not exceed or should not reach the material's melting point. So the temperature and pressure, the criteria is that it should not reach the material's melting point, or it should be slightly less than the material's melting point. So it's a heat treatment process where the material is subjected to high temperature and pressure, where the temperature and pressure is less than the material's melting point. That will cause the loose material to become a compact solid piece. So this is how the chemical sintering occurs. So in photoconductive cells, they are made by chemically sintering the powder of this cadmium sulfide or cadmium selenide, like these type of semiconductor materials, into tablets of required shape. The electrodes, they are deposited on this tablet surface. You can see this red part is the photoconductive semiconductor material like cadmium sulfide or cadmium selenide, whereas this gray part is the electrodes. These electrodes are deposited on this tablet surface, in the form of interlocked combs. You can see the electrodes, they are deposited in the form of interlocked combs over this tablet surface. And basically gold is typically used as the electrode material here, and for added protection a transparent plastic cover is usually included. So these are the contacts from where the wires will come out. These are the terminals. This is the photosensitive photoconductive semiconductor material. These are the electrodes, and the electrodes, they are in the interlocked comb form. Now, why such a structure? Why we are going for such a structure? What is the reason behind this zigzag? You can see this photoconductive material. If you see, you will conclude that this photoconductive material is present in the zigzag form. So why this type of construction? What is the reason? The actual reason is two common photoconductive semiconductor materials that are commonly used. They are cadmium sulfide, having the band gap of 2.42 electron volt, and cadmium selenide with a band gap of 1.74 electron volt. So there are two types of commonly used photoconductive semiconductor materials having these band gaps. Now, as you can see, the band gaps are too much. Because of these large band gap energies, both the materials, this cadmium sulfide and cadmium selenide, will have very high resistivity at room temperature, which will give this bulk samples a resistance resistance much larger than required for practical applications. So what is happening? Because of the large band gap of this photoconductive semiconductor materials like cadmium sulfide and cadmium selenide, their resistivity is very high, which will make the resistance of this bulk samples to be very high than that required for practical applications. Now, what is the thing that we need to do? Now we need to overcome this problem. We need to make the resistance a little bit lower. or we need to reduce the resistance in such a way that it is appropriate for the practical applications. So to overcome this problem, this special zigzag pattern, zigzag pattern or zigzag structure is used that will minimize the resistance geometrically and provide maximum surface area for the detector. How? We know R is equal to rho L by A. We are knowing that the photoconductive semiconductor material is having very high resistivity, which will make the resistance to be very high than that required for the practical applications. So how to reduce the resistance? We can reduce the resistance by increasing the area and decreasing the length. So how we will be doing? So this is the photoconductive material. This is the width. Area is equal to width into length. So this is the width and this is the length. So if I increase the width, the area will increase. The area is getting increased. Now I need to decrease the length so that my resistance will increase overall. So how to decrease the length? I will make the length to be very minimum and I will keep on increasing this width. I will increase this width so that the area will increase and length will decrease and overall the resistance will decrease. So now this area is decreased. Now the area presented to light is large for maximum exposure, whereas the electrical length is small, which reduces the nominal resistance, like I've told you. But the strip is very unpractical. It will have a very high physical size if I keep on increasing this. If I increase this width, so that my resistance will decrease. If I increase the width in order to decrease my resistance, which will make this photoconductive cell to have a very high physical size. So that's why the strip is folded in back and forth configuration to reduce the physical size. You can see it is folded in back and forth configuration to reduce the folded size, so a very large width strip can be incorporated in a very small physical size. So this was about the construction of photoconductive cell. I'm ending this class here. We'll continue with the photoconductive cell in my next lecture also. Thank you.